All right, everybody, so this is the second review presentation I have for you, and it's on literal equations. So at this point, we've reviewed solving equations. So you should be able to easily, quickly solve any equation that looks similar to this one. In fact, the majority of you probably can determine the answer, x equals 7, pretty quickly. Here's the steps in between for those of you who are like me and like to write everything out. It's inverse of minus 4, so add 4 to both sides and divide by your coefficient. Now, solving literal equations occurs when you have more than one variable in the equation. So you're not solving, you're isolating for one of those variables. So, for example, if I give you this equation and I ask you to solve for x, your steps would be almost exactly the same. We would add 4y to both sides. Notice that it's 4y now instead of just 4. And also notice that we cannot combine 10 and 4y. You can only combine terms that have the exact same combination of variables and exponents. Okay? And then we divide by our coefficient 2. And then we always ask ourselves, can I simplify anything in this equation? Yes, I can. I can simplify 2 over 2, I can simplify 10 over 2, and 4 over 2, especially these coefficients over here on the right-hand side. So your final answer for this example would be x has a value of 5 plus 2y. So to summarize these steps for solving a literal equation, you're going to identify the term containing the variable you're isolating. So we isolated for x in this equation. We first move all other terms to the opposite side of the equal sign, and then finally we're going to divide by the coefficient of the variable we're isolating for, and then, if possible, you're going to simplify. Always ask yourself, can I simplify? So here's another example for you. Again, here's our steps to solve. I want to solve for a, so this is the term I'm isolating for. I'm going to move other terms to the opposite side of the equal sign. So here's my other term. I'm going to move it by subtracting inverses. Okay, so 3 times a number has a value of 9 minus 12b. Again, I cannot combine these two terms because they don't have the same combination of variables. Finally, we're going to complete the inverse of the coefficient of the variable. So 3 is my coefficient of the variable I'm isolating for. So it's 3 times a, so I do the inverse and divide by 3. And then finally, can I simplify anything? Yes, I can simplify these terms over here on the right-hand side. 9 over 3 simplifies to 3, and negative 12 over 3 simplifies to negative 4, with your final answer being a has a value of 3 minus 4b. So again, a couple of things you should notice. Your final answer isn't just simply one number. It's a combination of terms with numbers and variables, right? That's the difference between solving an equation and solving or isolating literal equations, all right? And these steps are going to apply to all types of literal equations. Okay, see if you can use those steps and try this example on your own. Your final result should be y has a value of 6 minus 1.5x. Now keep in mind that 1.5 can be written as the fraction 3 over 2. So you didn't necessarily have to change that to a decimal. You could have left it as 3 over 2 because that's a simplified and proper fraction. Here's your steps in between. I identify my term that I'm isolating for y. I move the other term beside it to the other side or opposite side of the equal sign, and I divide by my coefficient 2. Final step being simplify these terms on the right-hand side, 12 over 2 and negative 3 over 2. give this example a try. See if you can do any better, or see if you can perform as well as you did on the first example. We're isolating or solving for y. Your result should have been y has a value of negative 2.5 plus 0.5x, or negative 2.5 plus a half x. Here are your steps in between. Please note that you could write these decimals as simplified improper fractions. So negative 10 over 4 simplifies to negative 5 over 2, just like 2 over 4 simplifies to 1/2. So if you have those fractions as opposed to the decimals, your answer is correct. You can write the improper fraction simplified, or you could convert it to decimals, but you should not leave it like this, because there's still simplification to be done. Okay? What if you're given an equation with all variables, no numbers, no coefficients, just letters? You would still use the same process. So you're going to identify your term containing the variable you're isolating. So given this equation formula, b equals x times z plus y times w, we're isolating for z. So this is the term that we're isolating, okay? So the first thing I'm going to do is the opposite or inverse of this. Subtract y times w. Notice that I can't combine that with b. They're not the same combination of letters, so they just simply get put side by side on the same side of the equal sign. And I'm still going to complete the inverse of the coefficient of the variable. So this says x times z, so what I would do is divide by x to get z by itself. Is there any simplification to be done? No, there's no simplification in this instance because there's not an x anywhere in the numerator as well as the denominator. That's when you could simplify. Okay, so same steps. Those steps apply to any equation that has a combination of numbers and variables, or even if it's just variables. Okay, so you give it a try when you're just working with variables. I'd like for you to isolate the letter W in this equation. And this should be a formula you recognize. This is the formula for finding perimeter. Your final result should have been 1/2 P minus L equals W. So if we're isolating for W, we're going to move this term 2L to the opposite side of the equal sign. I can't combine these different combinations of letters. And then I'm going to do the inverse of the coefficient 2 times W, so I would divide by 2. Is there simplifying that can be done? Yes, there is. 2 over 2 simplifies to 1. So this coefficient in front of the L is really a 1. We don't have to write it. And then 1 divided by 2 is 0.5. But you could have left that as 1/2. So you could have the fraction 1/2 here in front of P instead of 0.5. So that is what I have for you for reviewing literal equations. If you have any questions, let me know.